Okay, so today we will see how to create peer-to-peer network and compare the peer-to-peer network to the client-server model. We will start by very simple peer-to-peer network, and the peer-to-peer network is going to be extended to more advanced or more extended peer-to-peer network. And then we change the peer-to-peer network into client-server network or client-server model. So let's start by very simple peer-to-peer network. The simplest peer-to-peer network is a network with two devices. Actually, from the previous labs, maybe you think we always need a switch to have a network. But in fact, no. Maybe we can have a network without a switch, without a hub, without a router. But it is going to be very small network, like the network between two devices. But how to connect the two devices? The connection between the two devices is going to be a copper crossover. We cannot use the straight through cable. We have to use the copper crossover. So select the copper crossover and connect between the two devices. In fact, if you have two laptops, you can connect these two laptops by a wire, and this is going to be a peer-to-peer network. You can transfer data between the two devices. You can share files. You can share printer. You can do many things between the two devices. And this is the simplest peer-to-peer network. Let us put this network in action. To put this network in action, we have to assign IP address for the two devices. So let's go to the desktop and IP configuration as usual and select the most simplest or the simplest IP address is i10.10.10.11, and the subnet mask is 255.0.0.0. And this is no need for default gateway, no need for DNS server, because this is a peer-to-peer network with two devices. Okay, let's again go to the desktop of the second device and put 10.10.10.12. Okay, and this is the second computer, and change the computer. We will need these later. This is Ali, and this is Osama. Okay, this is Ali and this is Osama. They are two computers connected together to transfer and share network and share printer. Okay, so okay, we assigned IP addresses. We know this is 11 and this is 12. We can go to the command line and ping. Let's see the IP config of this network of this device. This is 11. So we are going to ping 12. So 10.10.10.12. Let's see if they are connected. They are connected. Okay. So it's a network, and this device can ping that device, and this device can ping that device. This means we can share files, we can transfer files between the two networks. But go for you. No need anymore for the cross cable. If you don't have a cross cable, you can use the cross copper, the copper straight through. But in fact, this is just a simulation. But a real world application, if you have two devices, the currently the network cards can detect if this is from device to device or from device to switch, and it turn it turn automatically the cable from straight through to cross cable. Okay, so no need to assign cross cable in real world application. Okay, so let's extend this network, this peer-to-peer network. By the way, we can extend it because sometimes a peer-to-peer network has uh, in mind, we may remember that or understand that the peer-to-peer network is like a mesh topology. Absolutely not. It can be star topology. The peer-to-peer network can be star topology. As we will see now, we can go to this wire and remove it and add a hub. And instead of having only 2 devices, we can add more devices. So go and add more devices. Okay, add more devices. And this is also a peer-to-peer network, but extended peer-to-peer network because it doesn't have any kind of server inside the network. And also you can detect the connectivity between Ali and Osama, and the connectivity is successful. So also this way we understand that the connection between this is a topology. Topology means the construction of the network in real world application. But the type of the communication may be a peer-to-peer or a client server. This is just a type of communication model. So it seems like it is not peer-to-peer, but it is a peer-to-peer network, and it deals with all of these devices, maybe as a server or maybe as a host, according or a client according to the operation it is doing right now. Let's extend this network into more advanced network. It's still we can have a switch, and this switch also has a connection. We can have a switch, and this switch has a collection of devices, adding a collection of devices. Okay, connect the devices, and then connect the switch to the hub. Add a configuration to this device. This is Osama, this is Ali. So let us do this one to be 10.10.10.13. 13, okay? We have 11, 12, and 13. And this guy is Ahmed. Okay, this is Ahmed. Okay, Ahmed is a device for a client, and we want to make sure that the communication between Osama and Ahmed is working. Yeah, it's working. And the communication between Ali and Ahmed is working. Yes, it's working. And the communication between Osama and Ali is working. Yes, it's working. But so far, what we have done is a kind of peer-to-peer network because we don't have any dedicated server. And as I told you, this is star topology. This is also a star topology or a mixed star topology. And the layout is logical layout. Actually, we have 2 different layouts. We have the logical layout, we have the physical layout. The physical layout is the layout of our network inside. This is like a main wiring closet, and this main wiring closet has 2 devices. It has a hub and a switch, and the connection, it makes all of these to the same, adds or connects all of these to the same LAN. So logical and physical. Physical means the diagram of the network inside the building itself. You put the servers in a specific location in the first floor. You put the devices in lab 1 in a specific IP address range. You put the two LANs in the second floor and so forth. So this is physical, but logical is the distribution of the devices and the switches with the corresponding IP address range. Okay, returning to our network, we can find we still have a peer-to-peer network. But now we want to extend this network to be a client-server network. Okay, let's extend it to be a client-server network. Let's add something interesting here. Let's add a server. And this server is this time is going to be or email server. It's going to be an email server. We connect this email server to the switch, and IP configuration is going to be 10.10.10.14, okay? And I think it's better to, this is email. I think it's better to add a note for this 10.10.10.14. And we need Ahmed's IP address also. So we click on Ahmed's device and go to the IP address and make sure that it is 13, and then add a note for it, 10.10.10.13. And the device for Ali, we need also the IP address of the device of Ali, and it's 11. So go to the device and add a note 10 dot 10 dot, what happening, dot 10 dot, I forgot, 11, maybe 11. Okay, let's make sure that it's 11. Yeah, it's 11. Okay. This is the email server. Now, this network is changed from peer-to-peer network to a client-server network because we have an assigned server here, an email server. But the email server is not a server without a service working on it. Open the device, go to the services, click on email, and make sure that SMTP and POP3 is working. These are the two services on the email. SMTP is sending an email and POP3 is extracting an email. So put the domain name to be, for example, hct.ac.ae and set it. And make user for Osama, user for Ali, and user for Ahmed. So let us make a user for Osama, and the password for simplicity is going to be the same, Osama. And add this user. Add another user for Ali. The password is going to be Ali. And add this user. Add Ahmed. And another one for Ahmed is the password is going to be the same as the username. But in real world, the application is not recommended to use the same username as a password. The server now is set up and the service is working as is on, and it can send and receive emails. To work with email, open the desktop and go to the email and make the settings. This is Ahmed, so this is Ahmed. The email address is ahmed@hct.ac.ae. and the incoming mail server, the outgoing mail server are the same. So this is 10.10.10.11, 14. And also the same thing is they are the same server. The two services are set on the same server. And the username is Ahmed and the password is Ahmed. And save. And that's it. We have an account for Ahmed is set up. Go to Ali and make or set up the email configuration for Ali. The email address is going to be Ali and at hct.ac.ae. This is the email address, and the incoming mail server IP address is 14 as we see here, and the outgoing is the same 14, and the username is Ali and the password is Ali, and save it. Okay, and also we set the email for Ali and Ahmed. Now we can also set for Osama, but yani, the same thing applies. We can go and make the same procedure for setting up an account on Osama's PC, but it is a repetition of the work. You can do it yourself. I leave it as an exercise for you. Return to Ahmed device, and Ahmed want to send an email for Ali, telling him that it is sunny today, we can go for a walk. Okay, so compose and send it to Ali. The subject, go for a walk. And the email body is hi, Ali. Why can't we go for a walk today? It is funny. We will enjoy it. Okay? Waiting for your reply. Yours, Ahmed. And send. Okay, and close this device, the device of Ahmed, and go to Ali's device and open it, and go to the email, and this time is receive. Receive means it's going to retrieve the email from using the POP3 protocol. So receive is going to receive, and you will find, or Ali is going to find an email from Ahmed, and he's going to read the email. Hi Ahmed, hi Ali. Why can't we go for a walk? It's sunny, we enjoy it. Waiting for your reply, and it's signed by Ahmed. And Ali is thinking about replying to this email. So reply to this email and saying, why not? Is good idea. Let's do it. Okay? Okay, let's do it. And send. Of course, we go back to Ahmed's device and receive. This time is going to receive an email from Ali saying, why not? Let's do it. It's a good idea. Okay? And Ahmed is happy now because it receives the email, the reply email from Ali. Okay, this is how the service are working, and how the how the POP3 and how SMTP protocols are working for sending and receiving an email in the network. And we implemented a client-server model, and at the beginning, we started with peer-to-peer network, and we changed it to client-server network. And we used the email services to construct an email server, and it works fine without any problem. Last thing is to see the layers and the contents of the layers, the 7 layers. we know that we have 7 layers. Our model has our network model, or OSI network model has 7 layers. And Packet Tracer working with the 7 layers or the OSI model. We have also this TCP/IP, and it has 4 layers. But here in Packet Tracer, we are working with the OSI layer, which has 7 layers. The first layer is physical layer. The second layer is data link layer. The third layer is network layer. And the fifth layer is session layer. The fourth layer is transport layer. And the fifth layer is session layer. And the sixth layer is the presentation layer. And the last layer, or the seventh layer to the top, is application layer. Okay? These are the layers, and each layer has a specific task in the network. Let us see in practice how the information in the layers are changing while we are sending an email between Ali and Ahmad. Okay, so let's open the simulation and reset the simulation and go to Ali and compose an email. This time, compose an email and send an email. We are going to use the SMTP. So this send to Ahmed at hcp.ac.ae, and the subject is going to be hi about math marks. Hi Ahmed, I'm sad I got 30% in math course today. Okay, and is going to send this. Before sending it to Ahmed, we make sure that we are in simulation mode, because we need all of this information. Okay, let's send it and close this. We stop. It is stopped already. You can open one of these, and we will find, because this is out layer, it is out, means out is going out of this device. And because it is going out of this device, it appears only in the out. Okay. For the layer 1, we have the fast Ethernet frame, because the layer 1 is the physical layer, and its job is to convert signals back to frames. And the layer 2 is the Ethernet layer, or the data link layer, and it has the MAC address information. Here we have 1B49 and B2CD. But we don't know exactly what is B49 and B2CD, or 2CD. B49 and 2CD. What are these MAC addresses? Let's return back and return to the real time and check the MAC address of this device. Okay. The MAC address of this device is B49. B49. This is the MAC address. The MAC address of this device is B49. And the destination MAC address, okay, we can even stop here, and we will see the MAC address B2CD. This is B2CD. Okay, and here this is B49. Okay, so return back to the simulation and go back to the device, go to the email, and compose an email again to Ahmed. Oh, by the way, we don't have to close this window. No need to close it. Ahmed at hct.ac.ae, and the subject is hi, and the body is hi. Okay, and send this. Don't close it. Okay, we will need it again. Open again, and we see that we know now that 9449 is the source device, and 2CD is the mail server. And the IP address is the source IP address is 11, and the destination IP address is 14. As we know, this is clear because we already written this here. This is 11, and the destination is 14. And the port number, the source port number is 1028. This means it is a random port number because this is the source port number, and the destination port number is 25, which is assigned for SMTP protocol. Okay, and we know now all the information in these 4 layers. Actually, in layer 4, we can find the session related. Layer 5, sorry, layer 5 contains the session related information, and for 6 presentation, which is decrypt and format the email, and for the application layer, maybe we will find information to collect or to assemble the email or deliver the email to the SMTP service. Okay, but it is not here. It's not found here in the packet tracer. For now, we concentrate on this information and follow what's going on while the packet is traveling from the source to the destination. Let's track it. Okay, so close this, and I wish we can move this for a little bit to the left. Okay, and this also can be moved. I think it's not moving. Why is this small? Let's do it. Yes, make it small just to see everything. Now it's okay. Okay, so let's continue. This is going to distribute because this is the hub, and we know that the hub is distributing all the information to all devices, or sorry, is broadcasting the message to all devices, and the device who is supposed to receive the packet is going to accept it, and all the devices who are supposed to reject it is going to reject it. Okay, this is the idea of the hub. But for the switch, we have another communication protocol, which is ARP, collecting all the MAC addresses of the connected devices and know exactly where to send the packet. So let's open this packet now and see what's going on. We have 2 layers only because, you know, 2 layers because the switch cannot work further than the 2 layers. It has this physical layer and it has the link layer. It has information about the physical component itself or the physical data itself, and it has also information about the frame or the MAC address. Okay, but it doesn't know anything related to IP address. It doesn't know anything related to session or presentation. All the above layers, it doesn't know anything about them. So it has only 2 layers. But these 2 layers is enough for him to forward the email or forward the packet to the correct destination. Let's go to the out layer here. So here we have 49. We remember that 49 is the IP address or the MAC address of the source device, and the destination MAC address is the email server. We of course we know before that because we are on the same network, the MAC address is not going to be changed for the PDU during its trip from the source to the destination. The MAC address is B49. This is the MAC address of the Ali PC, and the 2CD, which is the MAC address of the email server. Okay. Okay, let's continue and see what's going on. Continue again. Okay, let's stop here and see the packet again. The port number is swapped now because the packet is going to return back. we are going to, is like an acknowledgement or a kind of TCP communication. This is a type of TCP communication, and it is making sure that the email is delivered without any losses. So the port number, the source port number is changed to 25. It was random before, and the destination was is changed to the source, which is 1028. And the source IP address is changed to 14, and the destination IP address is like the packet is returning back to the source. And also, this is also swapped from 2CD to B49. Is opposite. Is opposite. You know, you can see this is the source before returning back the packet or returning the packet back to the destination or returning the packet to the destination. Okay? So we understand now how the information in the layers are changing during the packet trip from its source to the destination. Let's do something else. Let us go to real time reset simulation and go to the real time. And this time, let's complete this task, which is sending an email. I think it's sent. You can make sure that we have an email here from Ali, which is hi. Sorry, we have an email at Ahmed's device and receive. This is another email. Go for a walk. Okay, why not? Good idea. This is hi, what we sent in the simulation mode. Okay, and it is already received. Okay, and now we understand the construction of peer-to-peer network, starting from simple two PCs using a cross cable and extending this two PCs using the hub, and then extending more and more with the switch, and turning this peer-to-peer network into a client-server network by using an email server. We also simulated the simulation of the OSI model, which contains the 7 layers, and we see how the information is changed in the 7 layers during the trip of the PDU from the source to the destination. And that's all for today. Thank you very much and see you soon, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.